answer for this because he had no clue how I was going to be doing this today. So here's what they're doing. Today we're Dr. Shot. We're going to fix what we have wrong with Revit. So what we're doing is looking at how we can get piping to work right, how to do electrical, look at some HVAC stuff to how to do some custom fittings, and then some fast tips for what we're going to do. So is everybody ready? Have some goggles. Catch. You can't have my glasses. Sorry, I need those. Okay. So at the end of the class, this is what you're going to be able to do. At pipe accessories view behavior for schematic and single line, double line graphics. Everybody knows that single line and double line pipes work really well in Revit, don't they? Everybody's really excited. How many AutoCAD MEP users do I have in here? Y'all are sitting over there. Look at the guy with the horn already. We got all these guys in AutoCAD MEP looking at the Revit guys going, Next one we're going to do is we're going to talk about panel schedules. I don't have a shot for that, but I can shock you with that one. We're going to make sure that you know how to get your panel schedules customized and make sure that you got them working the way that you want them to do, and a couple of things you need to understand about limitations on panel schedules. The other thing we're going to do is take a quick look at a couple of duct fittings and a couple of different approaches on how to make this stuff work, something you might not have been thinking about before. And then it's a real simple fix to a duct fitting. And then we're just going to go through some day-to-day tips and then open the floor up for questions. So you guys ready? All right, cool. Let's get started. Thank you, Norb. You're done. Get out. Everybody give Norb a round of applause. You started all this crap. Okay. Our first treatment today is going to be about piping systems. So let's get out all this other mess here. And go to Revit. Let's talk about some of our pipe fittings and connections in here. So I'm going to switch my families, or switch over to my project here. All right, now this is a typical Revit single line piping drawing. Excellent look, right? Works for me, doesn't it? That's a real problem, man, because that doesn't look anything like what I'm used to seeing out of my other documents. So how do I clean this up and make it look better for me? Well, the first thing you got to do is you got to know what the fittings are doing inside of the families and how they work. And so what Autodesk did is they put a couple of extra components in all your fittings. They have model lines to actually show the tick marks, and they have some other graphics that are turned on and off using display configurations in here. So when you're in coarse and medium view, these model lines show up. But if you don't want them to be there, or if they're not right, they really make the drawings look bad. And if they're not defined correctly, they can really make it look bad in this case. So even in a single line view, I couldn't produce this. I can't send it out. So you got to think outside the box about how you're going to fix this. So the first thing you're going to do is take a look at the flange. So I'm going to edit that guy up quick and see how we can fix it. By the way, all these finished families are up and available up on the web along with our new template here. No, it's not our template. It's my template. Sorry. So I'm going to grab this guy and I'm going to pick Edit Family. So the first thing I'm going to do is I'm going to fix this guy because I really don't need that model line in there because I only show my tick marks on my fittings, not on my flanges. They're kind of redundant. So what I want to do is grab this guy real quick, pick him, delete him, load him up into the project. And once I get it loaded up in the project, overwrite it, and boom, I just took care of that extra tick mark. Now, how hard was that to do? Piece of cake. You got to think about where you're going to show your symbols and where you're going to show your libraries and how you want your fittings to be defined. So sometimes it's just a simple task of taking out something that you don't want. What about the tick marks on the fittings? Sometimes those things get kind of small, don't they? How do I actually edit that tick mark and make it the right size? Sorry, I'm killing myself with this stethoscope. Okay, so let's edit the fitting real quick. I'm going to come in and grab this guy real fast, edit the family, and take a look at what generates and controls the size of the tick mark. So as I go back and I look at this in the plan view, there's a lot of stuff going on in here, right? And that's really easy to read, right? That's the default setting. So I'm going to come back and change this to a little bit more legible in here, something that I can read on the screen. In some cases, they actually use parameters to control the size of the tick marks. In this case, they have a couple of them in here called tick size that actually control the width of that mark in there. Now, I don't want to take the tick out of here, but I do want to control how it gets placed in the drawing. So when you're looking at this particular example in here, you can see what the tick size is set to. And it's the flange outside diameter times 0.4. And I have absolutely no idea where they came up with that number. So I'm going to jack this guy up to 0.75, pick OK, and then what I'm going to do is load that back in the project again. Overwrite that existing one with the parameters. Ticks are a little bit too big, but it's a little bit bigger, and you can see how this is going to work. The point here is that it's a little bit of trial and error. You have to mess around with them until you get them the size that you want. So I can go back and edit the family again here. Go back and just change that simple formula in here and make it something like a 0.5. And then when I do that, I pick OK. And then I load this guy back into the project, overwrite it, overwrite with parameters, and it looks a whole lot better. So it just takes a few clicks, and you can clean this stuff up and make it work a whole lot better for how you want your plans to work. And we know that everything else looks exactly correct, right? How about that ball valve? That one doesn't look like anything that I use in there. I use isosymbols, and that's not an isosymbol, man. The isosymbol's got two triangles with a circle in the middle of it, right? How many of you guys use nested families? What's the deal about using a nested family? Where do you want to use it? What's the rule about using a nested family that's a symbol? It's annotative, but it also only shows up in the plane that you insert it in this case, the reference plane. So I can actually use a nested symbol like that and edit this block and edit the behavior of it. So if I grab this guy and edit the family, and I go in and look at this one is actually using model lines. It's not at all what I wanted to do. So when I go in here and I look at this particular one, I'm going to go in and drop those model lines out and just get rid of them out of the model because I don't want to use them to do a plan type symbol. Let me show you one that's a little bit farther along and one that's a little bit more complete. So I'm going to open up another family that we got loaded up for you here. Another ball valve. Grab this guy and open him up. And so when I look at this in a plan view, I actually have the nested annotation symbol in here. So if you go and edit this is one of the things I do a little bit different in here. I do use dimensional parameters on this to control the size of it. So if I need to make that symbol a little bit bigger or smaller, when I nest it in, I can do an associated parameter and actually change the tick mark size and make it a little bit bigger or smaller. And all you have to do is load it in your project and associate your parameters. Life is good. So I got the symbol set the way that I want. What in the world was that? And when I go back and look at this guy in the plan view, let's close him out. That's the way I want it to be. Now, because it's an annotation symbol, it only works this way from a top view. What do I have to do if I'm working in like a side view or an elevation view? Still got to use the model lines. You can't get out of that. Okay? So you still have to drop them in the same way that you did before, but you can control them and you can time so that they match the body diameter and they match the size of the symbol that you're putting in here. So I'm not as much worried about it for elevations, but at least in schematic plans I get it working the way that I want to. So I'm going to load this guy into my project, put it in here and drop it in. And this time when I go and drop him in the project, he's going to drop in and look the way that I want. Of course now I've got to change the size. That's what's called user error. So I go back to my systems and do my pipe accessory again. At this time I tell it to be a 6-inch valve. And drop him in, put him on my line, life is good. Pretty cool? So it's just a couple of real simple things you can do to make these fittings work a whole lot better. And the beauty of it is I got all this stuff sitting out on the web for you. So when you get back and you go to the class site, go and grab these symbol files and grab them and use them in your projects, and you can edit them as you need to for things like gate valves, that kind of stuff. Now I do have one rule. I don't put my actuators in with my symbols. My actuators are all separate symbols. We started doing that this year because we actually track them separately. And the reason why we do is because we figured out how to link Revit MEP to AutoCAD P&ID. That's scary. That's a whole other class. So I want my symbols to be the same in both applications. Pretty cool? Any questions on that one so far? Yeah. If it's an annotation family, it does resize itself. Watch this. If I change the scale of the drawing, if I go in here and set the scale to like 1/4 inch, it resizes. Okay, that's because it's annotative in that case. So you just need to be aware of it. Because I did it as a nested annotation symbol, it'll scale itself up and down. Okay? And notice that it stays connected. There's a little bit of a gap in there, but when you go to print this thing out, it'll still be nice and clean. Okay? Remember, it's picking the gap up from the actual flange width on there. And you can cheat that. A buddy of mine, Emmy McGann, actually is the one who helped me write this. How many people know Emmy? Anybody ever met Emmy? She's one of the best application engineers I ever met, and she was my co-author on the Revit MEP 2011 book. Emmy is the one who came up with this method and how this stuff works. and we've adopted it on all our valve families. And it gives us some great looking drawings when we spit them out. Okay? All right. Now let's take a look at a couple other things. How about panel schedules? Let's go switch views here real fast. Get back over to our PowerPoint. Oh, by the way, we forgot some rules. We're going too quick. Set your phones to stun. Make sure that you have your class ID as MP1414. All right? By the way, that's another one of our recent projects right here. That's the Mon Valley Bypass Facility there. All right, so we're going to do our single lines, panel schedule. We'll skip through all this. We don't need to sit down. Y'all hate PowerPoints too, don't you? All right, so that's our tick symbols for pipe fittings, annotation symbols for accessories and plan views, and then adding model symbology. So it's real simple how to get that stuff dropped in and added in. Let's talk about panel schedules real quick. How many of you guys are actually doing panel schedules and customizing them? How many of you guys like to use wire sizes in your panel schedules? How many people don't like to use the wire sizing tools in your panel schedules? Okay, you got to know how to set up all the electrical settings to make this work correctly. We actually found this problem about 2 weeks ago, where sometimes we would get 3 wires in a panel schedule showing up when we really should just get 2. So there was a couple places that we had to make some adjustments in our wire types to get it to work correctly. We also customize all of our panel schedules that we use so that we can adjust their size, their thickness, everything else. So we're going to take a look at those real quick. So let's go back over to this guy. We're also going to take a look at editing the scheduling data formatting and how you can change the values in the schedule. And we're also going to know the limits of the circuit and equipment parameters. So this is like a typical panel schedule. Does anybody have anything that looks like this? Okay, you ever having a problem getting a 2-wire to show up like this? All right, so let me show you how to fix that first. I'm going to start off by going over to my template that I have for you guys. Yep, close that out. And I'm going to open up my AU MEP template. All right, so this is just a raw template in here. And I'm going to start off by looking at the panel schedules that we have. So we start on the Manage tab. I can't see all my panels in here. Let me get that sucker a little bit bigger in there. Panel Schedule Templates. Manage the templates. If you want to create a new one, you have to start with Manage. And once you have one in here, you can actually duplicate this. So I'm going to start off and have a new one in here and call this a 3-phase panel. Get that added. And then what I'm going to do is pick OK. And then I'm going to come back over to Panel Schedule Templates and edit the template. You go ahead and open that up. So you have several template options in here that control how this thing is sized. First of all, it has a fixed width. So if you want to make it bigger or smaller, you have to actually adjust it here. You can change the schedule to vary itself based on the maximum number of single pole breakers or be to a fixed constant value. So if you're not going to have a set number of breakers in here, you can flop this back and forth either way. You also can control how the load information is going to come into the schedule, whether it's showing load by phase, loads by split columns, load by shared columns, or mirrored phase columns, either one. You can also tell it to show the column values as either load or current. So those are a couple things that are going to make it a little bit simpler for you there. When you get to the load summary, you can tell it to use either loads that are connected to the panel or a constant set of load calculations. So in this case, what we want to do is we want to add a wires table in here because this is going to make the schedule crunch down. That fixed width in there is what controls the size of the schedule. So anytime you insert a column, like we're going to put one left as selected in here, it's going to insert it on both sides. That's the beauty of the panel schedule in here. But notice that everything compresses. That's because of the fixed width. So if you need it to be wider, you have to go back into options and change it there. But if I change a column width, it actually changes it on both sides. So I can adjust it both ways. Once I get this started up and defined, I can go back and I can throw some line work on here and make it look a whole lot prettier. So I do lines outside and lines inside. Now the next thing I want to do is I want to add a parameter in here. When you're adding parameters to a panel schedule, they have to be defined by electrical circuits. And this is one of the things that we found out, is that when I assign a load to a panel or to a piece of equipment, you're limited to where you can assign parameters to the equipment that will show up in this schedule. You have to define it for the circuits. They also have to be instance parameters. If you try to do them as a type parameter, they won't work correctly in here. So what you want to do is go in and pick one of the predefined parameters in here. So I'm going to start off by looking at what I've got loaded already. and I want to add wire size in here. So I scroll all the way down and I put wire size in, and it populates both columns in there. Pretty simple. And then you can come back in and you can change the font. You can make it bold. You can make it light. You can do whatever you want to. You can change its alignment in the cell. You can tell it to be vertically aligned along the bottom. Life is good. Sit there and change all this and throw it up there as bold. Now this is where the fun and games came in. We couldn't get that two-wire system to show up. So what we had to do was go into the electrical settings in here, and we had to mess around with the wire types. So when you go into wire types, you see how you have the THWN in here? And see how this says that a neutral is required and the neutral multiplier is set to 1? When you have these two values set, it will always show 3 wires in that schedule. To make it only show 2 wires, what you want to do is add another one in here. So I'm going to call this in and call it THWN 2-wire as another type. Because the name really doesn't matter here. This is just what controls what wire type you select. Then you go in and you pick copper. You pick the rating that you want it to be. Pick the insulation. And then I set my neutral multiplier to 0 with no neutral required. As soon as I do that, I pick OK. Then when I go into a project and I start to assign electrical equipment, what I'm going to get in the schedule is what you saw in that PowerPoint. That's what will make this screen, that's what will make this show up as 2 wires. When you use that wire type on a piece of electrical equipment, then it will only show the 2 primary wires in here, the 2 wire types in here. Okay? Let's go back and look at another one in here real quick. How many people are doing MCC schedules? Couple people? What's the difference in an MCC schedule and a regular panel schedule? Got everybody doing motor control centers? Raise your hand if you do motor control centers. Couple people? Okay, cool. So with a motor control center, it's just a different type of a panel schedule template. I'm going to go in and I'm going to change from a branch panel to a switchboard. Once I get the switchboard up in here, I'm going to duplicate this guy, call it MCC. After I have that done, I'm going to go ahead and pick OK to get out of this. Go back to panel schedule templates, and then edit the template. Do my switchboards and my MCC. So not every panel schedule is the same in here, and what you have to do is you actually have to go in and add parameters that are unique to a circuit in here. So if you take a look at this, if I try to go and add parameters in here right now, picking a column, I actually can pick some stuff from electrical equipment. So if I go down here and I look and see what I've got available, the only thing I really have are the parameters that are in as a part of the project in here. So if you take a look, you've got a few things in here: total load, demand load, receptacle load, all these things that can be hooked up into the panel that are based on the electrical equipment. Okay? So now what I want to do is I want to add a couple of parameters into my project in here. So let's get out of this guy, cancel out of him. And what I'm going to do is go to my shared parameters and make a project parameter out of these guys. I'm going to go ahead and pick OK, or pick Add. And I got a custom shared parameter file for this. So I'm going to edit which one I'm using here. 2012 steroids, custom shared parameters. And now what I can do is things that are specific to an electrical circuit, like my overcurrent protection and my section number and my motor horsepower. So I'm going to go ahead and add that one to a project. Put that under electrical circuiting and make sure that it's an instance. Okay, but you have to check to make sure that it's applied to electrical circuits. You want to check electrical up here in your filters and get it in there for electrical circuits. Do the same thing for my OCP. Okay, my section number, okay. Go ahead and sell that to be to electrical circuiting, electrical circuits. And I'm going to add one more, the motor horsepower. And these are all just text information that I'm going to use to fill out in the schedule in here. Down to electrical circuits and electrical equipment. So now I have all those as project parameters. So when I go back and edit my schedule template again, and I do my switchboard, I can add in columns, and I can add some of the parameters that I added up in here. Now the key in here to make this work is make sure that you have it assigned to a circuit. And this is where the rub is. How many of you guys have things like horsepower assigned to your equipment? Okay, if I assign it to the electrical equipment, will it automatically populate the circuit schedule? No, it doesn't do it automatically. Even if you go in and try to edit it, it's still a separate field and you can't link the two of them together. The way we're handling linking it is we actually export this stuff out to a spreadsheet or a database and then sync the two of them together. That's one quick way that we can do it, and we keep a track of a lot of this stuff outside of the program. So that way, once they're synced, we can drop them back in and they stay current. So we don't have people editing the model as much. We actually have them editing a spreadsheet for the engineer or somebody else who would not be in Revit. And we've got it to where we can import spreadsheets back into Revit again and make those changes. We also do it with our SQL databases. So that's one of the ways you can get around this problem of not having them in the same circuit. But that's the only way you can get them to be assigned to a panel schedule is by going in and making sure that you have a similar parameter that you can use. It does need to be a different name. Okay? And then you got the same values that you can go in and change. Whoops, lost my glasses. All right. So now I've got that assigned and I can go through the same edit borders and do all that other good fun stuff to it. All right, outside, inside, okay. Finish the template. All right, so now that I got the schedule in there, let's go ahead and drop a couple of things in here real fast. Let me switch to another project. All right, I've created a drawing from this project. Save this guy. File, new. Start from my template. 12. Steroids, MEP, open, create a new project. Anybody else get that error? Yeah. Okay. Let's go back in this guy and close him. New, browse, 12, steroids, MEP. Okay. So now I can go and drop one of my families in here. I'm going to load a little family up. Do one of our little linear unit CCs. And I'll insert a piece of equipment in here. We'll put a pump in, insert, load a family. Yep, bad day there. Load family. Go to, let's go to water, GF, pumps. Drop in a little grit pump in here. And now it's real simple. All I have to do is put the equipment in and put the pump in. Put my mechanical equipment in. Drop my grit pump in. Hit escape. Drop my MCC in. Turn that guy on. And then when I create the circuit and assign it to one of those devices with my power circuit, I can select the panel if I've already got it assigned. So I just need to make sure that I got my power ratings, everything's set the same in here. So I go in and I check my voltage on the circuit, on the pump. Edit its properties. Got my voltage set to 480. So I set my distribution system on my panel to 480. Drop this guy in. Select my panel. Life is good. And then when I do the panel schedule and I drop that in, and it should pick up all that information. But you see how motor HP didn't populate? That's because it doesn't matter what's assigned to it. So the cool part is all I have to do is type it in, and life is good. Okay? So it's real simple. You can create panel schedule templates all day long and drop this stuff in. It's all associated with that circuit. Pretty simple to create. Okay, let's take a look at some other fittings in here and a couple of ways we actually are tracking mechanical fittings and other parts. How many of you guys have customized duct fittings? Okay. Have you ever had to do taps? You ever had a problem putting an equipment tap or an instrument tap on a duct or on a fitting? Doesn't like to stay anchored, does it? So what's another way to get around this? How about if you go and build a solid into a duct fitting and you use that as a connector? It's a different approach and a different way to think about how you're actually doing your parts in here. So since we do a lot of instrumentation, what we did was we added instrument taps right into the fitting itself. When we get done with this, I'm going to show you how to do a real quick variable tap length duct fitting in here and show you how I can change some of those fittings very quickly. So let's jump back over here again. Close this guy out. Now I'm going to open up a standard T family in here. So I'm going to go to my duct, Autodesk, fittings, rectangular, T's, and just pick a regular old, oops, that's taps. Pick a regular old rectangular T. Grab this guy. Now when you're working with these parts in here, you might want to add another solid in here. And this is what we did to start creating tap fittings in here. You need to have a solid somewhere in the fitting to actually make the connection. So what you have to do is you actually have to associate it with the plane in here. So I'm going to go back and I'm going to create a real simple extrusion. And what I'm going to do is set the work plane that I want this to be associated with. So I'm actually going to pick this top plane as the plane that I want to be assigned in here. And let's show this and make sure that we're getting the right one. Cycle through these guys. There he is. So I pick that top plane. And then what I do is I go and create the extrusion off of that plane. Now you can really place this anywhere in here. Sometimes I'll start off by snapping to a corner and just dragging in to make it correct. And then I'll just make it any size that I want in here. 2 inches, 1 inch, doesn't really matter. And I'll give it a depth of like -1 so that it's not going above the part. It's actually like a tap on the side of the component in here. -1 inch. Okay. After I have that done, I'm going to go ahead and finish that. And I've got the solid in there. Why do you have to have the solid in here? Simple place to put the connection onto. So once I've got the solid mapped, I just go back over and I create the electrical connector on here, tap it onto that fitting, and then I can put it into whatever group I want it to be. It can become a controls connection, communication, whatever you want to assign it to in that case. Now that I got that fitting loaded up, I can just go ahead and load that sucker up into a project. Get that thing dropped in, place it in here, and then I've got an electrical connection that I can use that I can actually make a tap off of this thing and load it up into that project. Did I save that thing before I dropped it in? Yeah, let me go back into it again. Let's save this guy first, then load in the project. Okay, and there's your tap fitting. You can go through and make your electrical connections. So how many guys are you actually? How many of you are actually approaching it this way? Anybody trying that one out? That one worked really well for us on a couple of really big projects where we were trying to put instruments right onto the equipment and onto the taps. So if you're going to put it on the fitting, you can actually model it into the fitting instead of having to go and screw around with trying to make it actually place on a part and get it anchored to a part. So a little bit different approach. There's other things that you can do to edit fittings to get them to work for you in here. Sometimes the changes are really simple in here. They don't have to be anything really complicated. So I'm going to go back and open my families up again and take a look at another fitting in here. I'm going to go to Autodesk, Fittings, Rectangular, and I'm going to go to Elbows this time. And what we're going to use in this case is a mitered transition elbow. One of the first things I learned is that it's a lot easier to edit something that's already here than something that's not here. And it's a lot easier to take a part that's defined than editing it from scratch in this case. So in this particular fitting, we got a variable over here for the shoulder length. And if I change one of these variables, it's going to change both of these because they both use the same variable in here. So the way to get around this was just by simply adding a couple of other parameters in here. I can call this one shoulder length left. Make it an instance. Then I come over here and grab this guy, add another parameter, and call it shoulder length right. Make that guy instance. Save him and load him into the project. Now the cool part about this guy, once I get him placed, I can actually have it to where it's got variable lengths on either side of the fitting in here. So you just go down through here and just change the shoulder length wherever it needs to be. Did I save that again? Am I missing saves today? That's why Norb is up here. He's out here to help keep me in line. That's a tough job. So let's save this guy. Load him into the project. Here we go. Grab him. There you go. Now I can have one that's 1 foot on one side and 4 inches on the other. This one actually came from one of our contractors. They wanted to have that variable tap length. And you can do this if you have like a transition elbow where one side's bigger than the other one. This is one, for whatever reason, they never put it in the program. It's still not in there after all these releases. So that's a real simple way to do the duct fitting in there. Okay. Let's talk about some other cool stuff that we've been using that makes our projects work a whole lot faster. How many of you guys are using Worksets on your projects? Okay. So I'm going to open up a project here and get started with a couple of Worksets. Now the cool thing about Worksets is that you can actually use them to control more than just the discipline that you're working in. How many of you guys actually break your Worksets up by level? So if I'm working in a multi-story building, I don't just have them by engineering, I have them also done by HVAC first, HVAC second, HVAC third. Okay? You ever have a project where you have a lot of different users? How about a project that you have multiple buildings? In our water treatment plants, the way we've got them broken down is I've got them set to where all of the buildings have their own work sets, and then they have their own discipline within that work set. So if the client has a building number list, we'll go and use those building numbers so they know how everything's supposed to be sorted and how it's supposed to be organized. So I might have building 19 HVAC, building 19 architecture, building 19 structure. We break them all up that way. The one thing you need to know about work sets, it's not a problem to have a whole bunch of work sets in a project. It's a problem to have a whole bunch of open work sets in a project. So you want to use the work sets to control visibility and make sure that everything is turned on that you want to use and turned off that you don't need. And by doing it by work set instead of by object style or any other instance, it makes it a lot faster. So it makes the models regenerate a whole lot quicker. So once you get this file set up as a central file and you get it defined, let's go collaborate and set this guy up. Do a little work set for him. You can see how I've got mine broken down in here. I've got them set up by HVAC, by linked files. I do work sets for linked files so we can turn off a linked background pretty quickly. And then we got them set by the different areas like process chemical, process main, how everything is defined in here. So if you really get confused on your projects, you can actually go through and you can turn work sharing display on. Has anybody ever tried this out? So I can do it by checkout status to show me which files have been checked out. I can go through by owners and have it display things by owners. And I can have it done by model updates, any one of those. So I can pick to have the work sets defined pretty quickly. And this is a real quick check that you can use to see who actually has got work sets defined, who's actually got them open, and how they're broken up in a project. Have you ever done a print by work set? Anybody ever tried that one out? So if you do your work set by system, you can actually do a printout with different systems color-coded that way. That's another way to approach doing it. And I did that in a couple of my water treatment plants. I had all the chemical systems in a work set. I had all the processed water in a work set. And then I had all the secondary systems, the ancillary systems, and the building supply systems in other work sets. So we just did a little color code like this and had them set up, and we also used color fills to make them print out in color. So it's a real quick way to actually see where everything's connected together. You ever work in a project where you got a lot of stuff and everything gets really jumbled? This is just a great way to take a look at those displays in here. Okay. How about view templates? How many of you guys have got a bunch of view templates set up? Okay. How do you have your view templates defined? Anybody? By which ones? So you got it by whatever the view is. Kind of a lot of little common stuff in there, right? How many view templates do you have set up in your project? You have 6 by default. Okay, let me show you what I got for you in the template in here. So I'm going to switch back over to my MEP template again. Open this guy up. Go to my View tab and go to View Templates real quick. So I've got them set up in kind of a similar fashion in here where I've got some electrical, plumbing, elevation, all that good stuff. This is how the default comes out of the box in here, right? So a couple things I've learned about view templates in here. Number one, I started turning off view range as an option with my view templates. Why would you want to do that? Why do you not want to have your view template controlling view range? Different level heights. If you ever do a project where you have multiple buildings in one file, like we do in our water treatment plants, I could have a building over here that's at building elevation 300 and another one over here at 301. And if you set your view range up in your templates to start at the current template and then go to the next level, what winds up happening? There's a really short view template in there. So we started turning view range off. And that's one of the things that you can set up in the default. So when you get the default set up like this, you want to make sure that you have those settings already in here. I'll lose my damn glasses again. Yep, I'm getting bad with my glasses. All right. I know, I just cannot remember glasses in here. So let's take a look at another real quick project in here. One's a little bit more detailed. And let's go to this guy right here. Another way that you can approach view templates in here is that you can go, instead of just using them by discipline filter, you can go in now and actually show by the different types and view discipline filters as separate categories. So they actually have this broken up a little bit differently than they did before. If I create a view and I assign a color fill to it, anything like that, I can set up a different view template. So in any case, in any project, as you grab one of these files and you create the view template from the view, like in this case, plan power, I get that defined. When you create the new one, you get more options in here. And there's a few things that they added in. They added in photographic exposure. So that's something new in here. And then if you actually put a color scheme on this, you can have a predefined color scheme assigned based on a view template in here. So that's one of the things that you can make it run a little bit smoother for you. You can do that with your rooms, your zones, and your spaces, and any other schemes that you want to use. All right. So let's see what we got for model categories in here that we can assess in here. The other thing that they added to the view categories and the view templates is the ability to do a filter list in here by discipline. So as you're setting up your view template, you can go in and say that the view filter only applies to like mechanical components in this case. And that actually shows you a different list where you just have the mechanical items that you can select from in the list. So rather than just showing all categories, you can pick it by discipline. And that makes it a little bit simpler in there. Now, one of the things that we started doing was adding subcategories to make it a little bit easier to control what we see in a template. So when you go to object styles, I'm missing my object styles. There you go. And I come down here to mechanical equipment. What we actually started doing was creating new categories based on the type of equipment. So I can have pumps. And I can have tanks. I can create anything in here that I want. And the reason why I would want to break a subcategory down is so that I can actually isolate items and have them to different colors in here. So as you go back to your object styles again, and I grab my subcategory for like tanks, I can come in here and say that's going to be a different pen weight, that's going to be a different color for that particular component. Now what we started doing again was editing how we set the solids up in our families in here. So I'm going to grab and open up a new family in here. And go to 2013. Content, libraries, water. I'm going to open up a tank real fast. And to make the projects run a little bit smoother, we actually grab the geometry in here and assign it to a subcategory inside the family in here. So we'll manage it right here. Go to our object styles, new subcategory, tanks. Give it any color you want, any pin weight you want. And then we grab all the solids that we need and put it on that particular subcategory. Save this guy and load him into the project. And so now that I've got it in that category, when I drop it in, it's already in here. Now the cool part about doing it in the family is that as soon as I load this up, it's already here. This is a different project that already has a whole bunch of different parts in there, but you can see how we can have all different types of subcategories in here, and they give you more visibility control over what you see in the model. You ever have a case where you want to show different pieces of equipment heavier than others? Like we have a lot of skid-mounted pumps that we do, and they get pretty detailed. So I like to drop them down to a little bit lighter pin weight, and then I put them into a pumps category and lighten them up. Makes it work a little bit smoother, makes the drawings look a whole lot bigger. But you can, once you assign the view templates in here, then you can actually control those. Or once you assign the subcategories, you can control them in the view template itself. Yeah. Run that by me one more time.
I found out that showing the 3D geometry kind of slows down the project when you have multiple pump fixtures, for instance. So is it easier to just do a symbolic outline of the equipment?
Is it easier to do a symbolic outline of the equipment rather than drawing a model in the plan and then just having a raw model? Is that what you're doing? Yeah, it really kind of depends on what you're doing here. How many of you guys are using manufacturer's pump from people like Flight? We've been downloading a ton of equipment from manufacturers lately. And when we started getting the pumps from Flight, we thought that was really cool. The only problem was they wound up being about 30 meg. The suckers are really big. So I'll tell you a way that I cheated in here. I actually took in their model into AutoCAD. Yes, I really did this. And then I used a tool in AutoCAD MEP called Create HLR. Has anybody ever heard of that? It's a little command that takes a 2D picture of what you see. The region command also does this in AutoCAD. So what I did was I took that and I used it to make just a 2D outline of what I saw in an elevation and in a plan. Once I got those 2D outlines done, I brought them into the family, and I had kept the solid for showing up in that view, but in elevation and plan, I put that line work in and did models for those objects in that particular point of view. It does make it a little bit smaller. We also had another project where the engineer actually took in a blower symbol that he'd been using on 50 other projects. That never happens, right? You have that engineer and that CAD guy that says, oh, I've got this symbol back here in the library. And they go grab that thing and they put it in the project. But it may not necessarily have things at the right correction point. So what we did was, to make this guy happy, is I went ahead and got the model for the blower, put everything at the right place, and it was just a raw model, just a simple box is all it had in there. But when we got to the plan views, I took the cut drawings that we actually got from the manufacturer, took the 2D drawing in, dropped it in as a plan view, as a plan symbol, and then that's what he saw in the plan. So he got his picture he was looking for, but we didn't have to go in the detail level of the model. So yeah, that's a great thing to do. Now, here's the tip about the view templates. Make sure that you're using those subcategories, okay? Because you can actually add a subcategory, and instead of just saying pumps, you could say 2D pump symbol. And you can actually make a subcategory for that. And that way you can control the symbol in visibility graphics and turn that on and off. That's another way to take advantage of the visibility graphics. And you can assign it to a view template if you've already got that family and that object style in your template. Does that make sense? If you're in AutoCAD MEP, the command is Create HLR. It's been around since Architectural Desktop Release 1. It's an old school command. Region will also do the same thing if you have a 3D solid. Okay? All right, so now that I have all this stuff defined in here, and I want to create a template from this view that has all those subcategories, all I do is come back in here to my view, right-click, create view template from view, custom. Oops, typing too fast. Pick OK. And then when I go to my visibility graphics model overrides, I can actually come in here and control it at this level as well too. This is one of the areas that people just don't do enough of. They don't go in and look at breaking things down. I will tell you that I used to have a lot of breakdown for things like air terminals and electrical fixtures. I had things like receptacles defined as subcategories. I actually backed away from that some. The only one I put into subcategories right now are mechanical equipment and electrical equipment because their definition is broad. It covers a lot of different types of components. You know, like mechanical equipment to me, that can include things like bar screens, filters, vortex grit separators. Yeah, can you imagine going in and say, yeah, it's all mechanical equipment? You know, you want to break it down and have a little bit more control over it that way. I haven't used it for schedules, no. How do you sort information in schedules? We can go off on a side topic here. How do you guys control information that goes into your schedules? How do you filter your schedules? If then equals, and you're doing program. Have you been learning from this guy? Have you been learning from Bruce? Because Bruce does that kind of mess. No, actually what we wound up doing, how many of you guys are incorporating omni-class numbers into your parts? All right, let me give you a real big piece of advice. If you haven't been doing omni-class numbers, you need to do that now. Okay? Because a lot of the databases that the programs are going to be getting linked to, omni-class is one of the things that actually tells an item what it is. So if I've got this tank here, and I go back and I edit the family, when I come down here and I look at the category and type, I can set what the omni-class number is. Now right now that's set to climate control. That's not right, is it? So what I really want to do is I want to put that into just supply and distribution of liquids and gases. And I can just grab like a primary category or a second category, but these are built into the program in here. And you can actually select any one of these items as a category to work from. So by assigning an omni-class number to it, that's something that you can use for a filter and actually break things down. Because you can filter by omni-class number. Okay? Now, another little trick that we did, because we have so many parts, and because we do so many different types of projects from process and everything else, I actually have a new shared parameter file that I just started putting into my new templates and into my new families. So I have a mechanical equipment type and an electrical equipment type parameter. And then you just go in and you add them in as a list, and then you can do your filters. You can filter your schedules by that. So I do all my water treatment equipment that way, and I've already got it set that way in the family, so it's already loaded when it comes in. Anybody in here using the shared parameter exporter? No? 1 o'clock in the labs, come back for families. I'll show you how to use that puppy. That thing is awesome. We use the daylights out of it. Okay. One of the other tips I got from my view templates in here, this is one that always aggravates the daylights out of me. Have you ever had a drawing show up and it has a whole bunch of different reference lines and reference planes in it? Anybody ever seen that? You got a bunch of green lines that show up everywhere? Okay, so when I set my view templates up, I've started doing this. I'll go into any one of these, and I go into my annotation tab, and I started turning some of this off and paying attention to what I have in here. So in my annotation categories, these two are controlled by a filter, so you might want to turn all these on, just so you can see the different categories. But I've gotten into the habit of coming in here and turning off things like reference planes and reference lines. I had a couple of my engineers that were trying to do a little bit of modeling with some parts in here, so instead of just going in and editing them in a family, they did a lot of in-place families, and they threw a bunch of reference planes and reference lines into my drawing. And then when they started working on the model, they also used reference lines that were associated with an AutoCAD drawing that they brought in to help me lay out where a pipe was going to go. I'm like, these things are showing up everywhere. So as a rule, we started turning off reference lines and reference planes in our view template, so when somebody got actually ready to print a view, we'd have them reapply the view template to make sure that everything's correct. And then all those funny little green lines that were showing up everywhere, they didn't see them anymore, and they didn't get back confused by saying, what is this line for? What's it supposed to be here for? So that's one of the things that you can do is turn those off right here. And I make sure that I do this in my annotation categories, my analytical model categories, and once a project is started in my imported categories as well. And I do all that with my view templates. I control all of those in my view templates. Most of the view templates that I look at from other people, they've either done model categories or filters, one of the two, and never really addressed the annotation categories. So make sure that you check this. And one of the things that you want to do is turn on all those disciplines so you can see everything that's turned on. Ever had done a view template and you've gone through and set everything up and then you realize that somebody has casework and everything turned on because you didn't show all the disciplines? Check that in your view templates as well too. Okay. Let's do a little imported detail in here and show you how I'm controlling some of my details. So let's close these guys. You close all the hidden. Okay. All right. Have you guys imported a lot of details? You've been using a lot of detail lines and symbols and stuff like that you bring in from AutoCAD? How many of you guys import and how many of you guys link? What's the difference between link and import? It's like an XREF, right? Yeah, and it can make the things get really ugly. All right, so I'm going to go ahead and bring a drafting view in here. I want to show you how we set up our AutoCAD drawings to make this work a whole lot better for us. I'm going to go into View, and I'm going to create a little drafting view in here, and just call this Test for right now. And then what I'm going to do is go ahead and import in a CAD file that I was using for the project here. This is my distribution panel detail. Now, there's a couple things that we did in this file to make it work a whole lot better for us. What is the equivalent to a layer inside of Revit in a drafting view? What's the equivalent item? It's a line style, okay? So what we did was we actually, to have our view template set up correctly, we went ahead and predefined some line styles to match the layer names that were in our standard drawings. One of our technicians just finished up a detail update project where he went through all of the water treatment details, every one of them, and got them fixed down to about 5 or 6 layers and all the details. Cleaned them up and made them all the same way. Worked on it for about 6 months because he actually had real work to do in between. And by doing that, it made it a whole lot easier when we could import it back in again. Now, you can have things like the different detail lines and line styles already mapped in here. So here's what I'm going to do. Before I actually import this guy, I'm going to go ahead and set something up in here. So I'm in a project right now, and I'm going to take a look at my line styles that I have. Manage. And I never can find these other additional settings, line styles. There you go. So if I look under my lines, I got a couple of them in here. I got dimensions and leaders. And these match the layers that you could have in a model. They already have a color assigned, and they already have a weight assigned to them. Now, when I go and insert this model by importing it and dropping it here into the file, let's take a look at how this thing is actually going to set up. All right, so I've got dimensions, and I also have leaders in here that are on specific layers in here, and they should automatically adapt to what's going on in the model. So if I explode this guy and do a full explode to bring the line work in, then what will happen is, you see how the leaders actually change from blue to red? Because I had a line style that matched the layer name, it's just like in old AutoCAD days. What would happen if you inserted a drawing that had a layer in it, but the same drawing that you were inserting into had the same layer? What takes precedence, the drawing you're inserting or the one you're inserting into? The one you're inserting into. So it works the same way in here. If you have that line style already defined, then when you insert it, it's going to assume the property that you want in here. And that includes things like the line weight. Because what's more important to us, the color or the line weight? So you want to go through and have those line weights assigned. Now this, again, this only works when you do an explode. And the only time I really do this is when I have a cleaned up detail in AutoCAD that I've already purged and wiped everything out. So it's a good habit to do that with your AutoCAD stuff if you're going to use that over and over again. Just makes it a whole lot smoother, and it makes it a lot faster to go and make it comply with your standards. This one actually was already exploded, yeah. This was one of his drawings. I've already fussed at him about not using leaders. But you get the idea in here. If I've already got the line style in there, I can use that to match the layer, and life is good. I don't have to worry about them being different. That saved us a ton of time in making sure that our projects look the same in AutoCAD and in Revit in both places. Yeah? Do you replace them with that? If it's a detail that I'm going to use, then yes. Yep. Absolutely. What we started doing is that when we started getting a bunch of details that were always going to be used in Revit, we would import them like this, but we would blow the text away and the leaders and redo them. We found that was a whole lot easier to do. We left them in there as a reference so they would know what to put, but once they got them in there, we just had all that stuff replaced. Yeah, we make them drafting views. I also, back at the office, I have a drafting view template that already has a bunch of predefined drafting views in it. So I have a project already set up that already has water details in it, HVAC details, plumbing details, all that good stuff. And then I can just copy and paste views from one project to another. Pretty simple. Everybody ever tried that before? Yeah, it's real simple. We don't spend enough time on our details, man. That's the one, when we talk about AutoCAD standards, how it looks better in AutoCAD than it looks in Revit. That was one of the ways we got around that. We matched the layers up to the line styles first, got them imported, and then we set up our master projects where we kept those masters. And once they became Revitized, that was the ones that we used. A horn in space. We finally got one. Yeah. Here, have a shot. Okay. Let's do that transfer project standards thing real quick. How do I get standards from one project to another in here? If I go to Manage, Transfer Project Standards, I can actually look at any one of my projects like my template. So I can go into my template and I can look at what I have. Now, I'll give you a piece of advice. You see this thing that says check all? Make sure you set that to check none. We did have a project where a guy went in. He had already gone through and set up a whole bunch of new view templates, had everything defined in the project. And then he thought he was being good. He wanted to make sure everything matched because we had a new template from the Corps of Engineers that we were going to use. So he went and imported everything. I know, I'm sorry. But what we wound up having to do was go back to an old backup file and restore the backup. And once we got the backup, then we went back and brought in what we needed to have in there. So you want to be careful about what you're importing in here. And you got to know that some things come across fine and some things don't. If I have a schedule that I want to bring across or something that has other data associated with, I can pick that main category instead of having to pick the subcategories, and I can bring it across. So like if I want to bring in a panel schedule template like the one I just made, I don't have to go through and bring all the shared project parameters in with it. Just importing the template will bring in the parameters. So that saves me some steps that go along with it. Okay? Pretty cool? All right. We got about 15 more minutes in here, so I'm going to go through some random stuff that I don't have in your book in here and show you some other cool stuff that we've been working with. Let's go open up another project. And I'm going to grab the arch model and look at this guy real fast. Go ahead and let it unload that link. All right, so for my MEP guys, how you like working with your architectural files in the background? It depends on the architect, right? You ever have any issues with things showing up in the right direction, the right wall types, all that other good stuff? Okay, so one of the things that we have a lot of fun with is getting our architects to understand how to control their wall types, how to control their elevations, and things like that. Can I show them something out of the template? Can I please? Show them something out of the template. Okay, cool. I'm going to show you something that we got in here that I don't usually show people. So do you guys copy monitor your levels and stuff into your project? Okay. So I'm going to switch over here to one of my elevation views real fast. This was one of the first things we did to help clean up and make modeling work a whole lot better for us. How many different level types do you have in your templates? 2? 1? 4? What does the level do for you guys? What is the level control? When you're in the MEP file, what's the main thing you use the levels for? Creating your views, defining your views. Again, because we work on multiple buildings within one site, sometimes when you do that import, it can get kind of confusing as to which levels you need to be using to define views. So Norb and I got on a little bit of a tear here, and we actually went through and started creating a whole bunch of new level types in here. And so we started by renaming this to be the primary datum level. And then we started adding levels for a 1/4 inch head, a little bit smaller head in there. Then we've got the ceiling level in here. And notice how my level's actually changing in here. And all these things start wrapping up to different elevations. And there's a few differences between these. Like our plenum level in here, this one actually is one that can be used to define a building story in here. And we can also have it set to where it's a story above and have it be a computational height in here. So the plenum level can actually still be used to define that particular elevation. When we do a primary datum level, like this one right here, this is one that actually bounds walls, and it actually can control views and its elevation. But we also have one in here that's just a temporary working non-floor level. And the working non-floor level in here actually is not used as a bounding element for spaces and not used as a bounding element for walls. It's just a temporary level that we put into our projects. So if I want to put equipment or something in there, but it's not going to define a floor level, that's what we use our working level for. So you want to be careful in here because you don't want to have a level that's going to be used to create a floor level, used to create a temporary level in here. And we actually changed their visibility for all of them so that they really jump out on the screen. So like that ceiling level in there that we're not going to define a view from, we went ahead and made it a completely different color. So as we copy monitor these, it's very clear which one we're supposed to use and which one we're not supposed to use. That made life a whole lot easier for everybody. Okay? Pretty slick? So that's something that you can have predefined in your template as well. Let's take a look at some other ones in here. I'll show you one that's a little more detailed. This is our shipping template here. We go back to the object styles again. You can see that we have everything assigned under mechanical equipment with the colors and the styles and everything set the way that we want in here. So in that particular case, by having all that in the template, we're not having to reinvent the wheel every time we start a new project. It's already there. And if I do in-place families, I can swap them over to one of those subcategories as well. So that's another thing that you can work with. One of the big things that we did to make life a whole lot better is we created something called the starter family. And so when we go to open our families in here, when we get into a specific category or a group like mechanical equipment, as we start looking at the different types of components like heaters, air terminals, heat pumps, whatever you have in here, we actually have a starter family. And in this particular case, we didn't create it as a family template. What's the difference in making something as a family template as opposed to making something as a family? What happens when you create something like this as a family template? It locks things on you. It locks these parameters down. So rather than having a whole bunch of Revit templates, we actually made a whole bunch of Revit family files. And we went ahead and pre-populated them with some basic shapes, some basic outlines, and some basic working planes in here. So when I go and grab this stuff in here and I look at it, it's already got things assigned. Like see how that's already assigned to the fan subcategory? So if somebody's making a part from scratch, they start from this family. They don't wind up going through and just making all the parts right from random because it's a lot of extra steps in there. The other thing we did with these is we went ahead and preloaded our parameters in here that we wanted for our schedules. And these are all shared parameters in this case. What controls a shared parameter when you put it in the file? How do you know that it's unique to that object? It's the what? The GUID. It's not the name. So by having our standard shared parameters in these starter families already, I don't have to worry about somebody loading up something in a project that doesn't match the schedules that we already have defined. Anybody ever have that problem? Have you ever gotten a file from a vendor and it's got, I love Takeo, man, they make the best pumps in the world. They got 50,000 parameters in there. If you go to like Trane or Boston or somebody that does these air handling units, man, they got parameters like you wouldn't believe. And it's great that they have all that stuff. We wind up wiping all their parameters out and putting in the ones that we have using the shared parameter exporter. But in this case, by having a starter family with all this information assigned, especially the electrical data, it saves us a huge amount of time when we go to start dropping these things in a project because all our schedules automatically populate. It just makes life a whole lot faster, a whole lot quicker. Now, when we got into things like mechanical equipment, what that meant is I have to have a whole bunch of different starter families. So I have a starter family that applies to water treatment equipment that's for things like tanks and pumps and filters and screens. And I'll use those and import the solids into those models, but I already have the parameters in there that I need. Then under the HVAC side, we have them for fans, air handling units, you name it. They already have all our parameters inside of them. That's one area that you can spend a lot of time and get a lot of money back out of it by having the starter families. Pretty cool? All right. A couple other things you guys probably need to know about. How many of you guys have gotten the latest piping update from Autodesk? One person? Okay. Go to your subscription site. About a month ago, they released a huge ductile iron library. It's got flanged and mechanical joint fittings. If you're on subscription, go to your subscription site and get up there and download that mechanical piping library. Especially if you're doing anything outdoors, anything process related, anything that uses mechanical joint, mechanical flanged. They have a huge library that just got added that is a really, really nice library in there. And yeah. Yeah, that's what they downloaded, was the complete AWWA library. Everything is in there right now. This just came out. We were talking to the development team and we found a flaw. Okay? And the flaw is that all of the connectors are on the surface of the fitting. Okay? And why is that a problem for mechanical joint pipe? Same with hub pipe. Why is it a problem? It's the length. It's the actual length of the pipe. So what you can do is you can actually move that connector. And this is where Autodesk said that was a problem. Because what happens when you take a pipe and you stick it inside of the fitting? What does it do? It immediately is trying to do hidden line graphics for that pipe inside the fitting. So we actually cheated and borrowed something from AutoCAD MEP. When we're trying to calculate true pipe lengths, I have a value called CEL, which is connector engagement length. And I've actually got that set up as a dimensional parameter, and I have it in a schedule. So in my pipe length schedule, it only applies to hub-type pipes, and anything that has a female end assigned to it, we actually add that CEL value to it. So then we get a value called true pipe length. So I've got a shared parameter and a formula that takes the actual length plus the CEL to create true pipe length, and that's what I use for my estimating. If you haven't done that, that's a really easy step. You do it as a calculated value. Let me set the schedule up for you real quick, and I'll show you how this works. I did that at the speaker social the other night. It was a lot of fun. Okay, so I'm going to go through and I'm going to toss in a couple of parameters real quick. On the project parameters, I'm going to add these as project just to make them real simple, but you can do them as shared parameters or project parameters. What's the difference in doing them as shared and doing them as project? So if I'm not going to tag anything with this, I'll do it as a project parameter, but I do want to use it in a schedule. So I create a new one called CEL. All right? And it's a common and it's instance specific. And what I do is I assign it just to pipes. I pick OK. All right, now I'm going to drop over into a plan view real quick. Drop myself a pipe in here. And just put one in. Really doesn't matter what it is, just have any type of pipe. Okay? Then I'll do a quick little schedule. I'm having aim issues today. My glasses must be really messed up. Schedules. And tell this guy just to apply to pipes. Okay, I'm going to go ahead and add in length as a value. And then CEL. Then I'm going to create a calculated value in here. I'm going to call this true pipe length. Okay? And it's going to be common length. They all need to be the same value. And that's real simple. I just click on this and I say length plus CEL. Okay? Don't have to add a space, but it just makes it a little bit cleaner. So now when I go and create, once I get this guy created, there's my 14-foot length, and then if I put in a connector engagement length of 2 inches, there's my true pipe length. Real simple. So if you're worried about getting true pipe lengths in your schedules and getting things quantitatively correct, don't worry about the connector being on the surface. If you're more worried, if you have a really big project, you really don't want all those hidden lines showing up in there. But if I'm doing estimating, then I'm going to go ahead and put in what I want for the engagement length to be. If you do it by instance, that means that you can do it by each individual pipe. But you could also do it by type if you wanted to. So I could actually go in and have my ductile iron pipe type in there and say, I want to include 2 inches for this because it's a mechanical joint pipe, whatever I want that depth to be. I just like to do it by instance so I can adjust it on every single piece. And that way I can get a really true estimate in that value. Pretty cool? Real simple thing to do in there. All right, questions? Where did I get this lovely lab coat? Halloween store. It was just a random thought. How many people are using the grid guide on the sheets? A little bit. That's probably the best way to do it, is to set up a grid guide, and then once you get the view in there, just align it with that grid guide. That's the best way to set that up. No, I don't monitor grids. No, I don't do that. That's too much monitoring going on. The only thing we really monitor are levels. Okay? What else we got? Oh, come on. I know you got more. There's one back there. How about the which one? Let me get you to speak a little louder so I can hear you. Okay. Yeah, the question is, he's got a filled region in his pump symbol, and he wants to turn that filled region off. Let me give you a different way to do that. Instead of having one pump symbol, have two pump symbols, one with the filled legend in it and one without, and then use a yes-no parameter to where you have a different type that turns that filled region on and off. That's a better way to do that because you can bring two symbols in. This is how we do a lot of our receptacles. Do you guys customize your electrical receptacles? Anybody ever done that? I've got some I've got the same family, but it shows single pole, emergency, everything else with different fill regions on them. So for every one of those, I have a different symbol loaded up. Then I pick it up and I do a visibility setting for it to turn it on and off based on the type. So it's just a checkbox that we do in there. We actually did that MCC panel that I brought in earlier. That's an example of how you would do that because you use those yes-no parameters to turn on different segments, different blocks, different regions in there. That's better than trying to just go and use another parameter to control the fill region itself. Yeah, I've tried to do that and it doesn't work because it's actually a nested symbol. Because it's nested, it doesn't work correctly. But if you do it with a yes-no, it works a whole lot better. Yeah?
When I nest my families, if I nest the coil family inside my air handling unit family, I can't control coil in the schedule in my project. Is there
Trying to do a nested coil inside of
an air handling
in an air handling.
unit in there, and if I edit the family, I can edit the coil data and put it back in and schedule it separately, but I can't go to the schedule and go to that coil and say change
You can if you do an associated parameter and you do it as a shared parameter, yeah.
But if you have multiple parts, I mean, your area
Yeah, then you would do.
700 parameters that it may not need because it may not have a heating coil.
Yeah, I actually, stop and talk to me in a minute. I got some on coils I can show you that'll help you in one of our families that we were working on. I'll show you how we actually handled that with a formula instead. Okay? Yeah.
So on going back to electrical panels.
Okay.
Whenever you circuit, whenever you connect equipment to equipment, it keeps the name. Let's say you name your panel this way, and you actually connect it to another panel. You'll see that it'll bring in that panel name,
Right.
Well, once you actually connect devices, by default it brings in the load classification, and then you can actually rename that as well. But whenever you hit the reset, check.
Yeah, reset the names.
Then it goes back to load classification.
Okay.
It's a way to just
He's going in and making updates, and his load classification is changing, and then he's doing reset names. Don't do that.
don't do that, yeah. But how do you make
'Cause-
it stay? Just by
Well, the first thing is don't ever, once you get your new, we actually don't let them change the names of the circuits until the circuiting on the panel is finished. That was a work process issue we got into because we had one guy who was going and making all these customizations as he went along. Then he started getting updates and started moving things around, and he started losing that information. So what we told him to do is just leave it all as default and don't change anything until you get to the end of a project in there. That just made it a whole lot smoother, and then he could override it whatever he wanted. Another thing that we did too is that you can drop using the load description and put your own circuit name parameter in. That's another way that you can do that. Yeah. And you just you make it an instance parameter so that you can assign it to each individual circuit, and then life is good. You can make it whatever name you want. So.
Is this the class you're going to have for shared balances?
Yeah, later. Why don't you ask me that right now? I'm answering questions about this. Come on, I'll tell you about that. Okay, what else we got? We got a couple more minutes here. I don't do that. I don't copy monitor walls. Don't do that. Yeah. Carriers on the back of wall-mounted toilets. That's a good one. Actually, we did model some carriers for that. The way we did it is we made it a nested family inside of a wall-mounted toilet. But here's the other thing we did. All of our wall-mounted toilets are non-hosted. I got rid of anything that I have. Has anybody ever had this problem? They get a bunch of families and they're wall-hosted. Okay, first of all, you have my permission to borrow one of these and shoot them, okay? How many times do you ever have MEP and architectural in the same file? You don't. And so when Warb and I started on this, we had all these other parameters that were coming for architecture for things that usually the architect would place, like plumbing fixtures. Well, the first thing we changed is that the architect doesn't place those anymore. The plumbing engineer actually does that. They're the ones that place them, and they copy monitor them back into the architectural file, or they just link them in, one of the two. But we wiped out anything that was wall-based. So now all of our fixtures are non-hosted. And what we do is if you want to show the carrier in there, you can turn it on and off. We also have families that have the carriers and families that don't. So if you put one in with a carrier, then the connection isn't at the back of the plumbing fixture. It's actually on the carrier itself. So that way you don't have to do all this extra pipe routing between the plumbing fixture and the carrier. We just did all the solid modeling in between. Who models the ceiling? How many people had this argument? Yeah. Who models the ceiling in your company? The architect? If you agree with that, say yes. Okay, you guys are crazy. No. What's the problem with having the ceiling modeled in the architectural file? You can put lights on the level. You can associate lights with the plane, but are they associated with the grid? The only way that you can lock a light alignment to a grid if it's in the same file as the grid itself. Okay? Now, we did a little cheating in here. What we did was we gave the architect a light masking family and let them go in and create that mask where they wanted the lights to be placed. It's nothing but lines. That's all it is. And then they drop in where they want a 2x2 or 2x4 fixture, mainly with the 2x4s. And so what we would do is we would let them put them in the architectural file and let that mask the grid. And then the electrical engineer would place the actual light. And that made it work a whole lot better. Now, one of the other things that we did too is in all of our fluorescent light fixtures, we include two connectors. We have a normal power and an emergency power, and we have both emergency and normal lighting in one file. Now, you got to be kind of careful about that because you are adding extra connectors. You can't turn the connector off, not yet. They're working on that part, and we might get that in the next release where you can turn a connector functionality off. That's one of the things that we've been hearing about already. So that would be something that would be really cool. You can say, don't take this connector into account. Then you can put all of them in there you want. Pretty cool? Yes, sir. Yeah.
So we have a wall-based family or wall-based toilet, right? So and then they move the wall as they always do. Now you've got to go and move it, right?
Stop. How do you keep a non-hosted family associated with a wall? When you do it, when you do an alignment, you align it by picking the back of you pick the edge of the wall first, then you pick the back of the fixture, and then you lock it. You do an alignment and lock it.
Up until a certain point. That's where we ended up doing the copy monitor trick, where you can copy monitor wall-based families.
Yeah.
It works.
I know it works, but we don't do it that way. We hadn't had a whole lot of success with it that way. We changed our workflow. That was actually easier to do. But yeah, we've been using alignment locks on a lot of that stuff, and we've never had a problem with that. We do the alignment lock. It works just like that. Anything else? Yeah. Uh-huh. If you want to keep the annotation the same size, it should stay the same size when you change scale. Relative size will be the same. Where we ran into a problem was where we had little lines going out to the side of it. So one of the things that we did to get around that was to create some not model lines, but symbol lines inside the family to make them go out a little bit further. And then we made them the same pin weight as the line itself. And that made them a lot cleaner. And that was another thing that Emmy did. And we also had them set with visibility graphics so that if you needed to turn them on and off, you could switch them on and off. It's another simple way to do it. It just created an associated. No, I don't ever do that. I don't care if they get scaled up or down because I want them to be the same size regardless of the scale. Now, what we don't do, and this is a big don't for us, is we don't take the body of the valve out for fine detail views. We leave the body in. That drives me nuts to see a valve in here in a nice detailed double line view, and then somebody's got two cones in there to represent a gate valve. Now, don't do that. Actually show the body of the valve because that's what you need. And if you're worried about somebody understanding what it is, put a tag on it. Call it out as a gate valve. We actually started that. We hadn't been enforcing that rule because they would just call them out and put a text on it and call it gate valve. We started enforcing labeling rules on our last two projects, and they're picking it up, and they like it a whole lot better because they can label it in a section and in a plan. And it's got the same information. And no problem picking it up. The other big one with us was taking the actuators off of everything. That was another huge thing for us. So we've got all these motor-operated actuators. We've got really nicely modeled hand wheels, everything. And our hand wheels are adjustable for heights, all that good stuff. Now, doing my control schematics in here, we have started using AutoCAD P&ID to do our control schematics for process control. You need to talk to me tomorrow. I got a class called AutoCAD MEP, Revit MEP. You did what? I don't know what time it is. Yeah, that's been, Norm and I each have innovation projects that we're responsible for. He's got the cool one, the geo thing that he's doing with Penn State. What is that? Huh? GIS. He's linking GIS and BIM. I've got data. He's got GIS. So we got a lot of really cool stuff coming up next year. All right, neat little applications. Who's got glasses? No, keep the glasses. You got glasses? Well, no, the sunglasses for crying out loud. And the people left with the glasses. They didn't stick around for their picture. All right, we're done. If you got glasses, your glasses, 3D glasses, come on up. We're doing a picture. That's at 1 o'clock. Why ask me that in the middle of a class?
So what?